So we've all been there, right? We have been debugging through our code only to step one step too far. Wouldn't it be nice if you could just go back in time and see what was before you got to the point where you see the problem? How we ended up with this faulty result. A classic debugging experience means you basically just have to rerun the application and go through it again. So sometimes you just have to go back and redo all of your setup because you need a specific state in the system, and hopefully you have unit tests and you can do this automatically. But if you don't, then this development cycle will kill hours, sometimes days of just trying to find where the problem is. I'm going to show you how now we can do it differently in Hantera. Filtrera just got this new feature that where it allows you to attach a tracer to the evaluation of a program to record everything that happens at every single step. And we've integrated this with Hantera's development mode so that you can capture all of the evaluations as they happen in your remote Hantera instance. And the only thing you really need to do is as you set up your dev mode, you just pass the trace flag. And if you do that, the system is going to automatically trace all of the evaluations and send them down to your CLI. We can see immediately that this file h_dev.trace was created in our local path here. And this is where all of those evaluations will be stored. Very, very basic app. It takes a list of numbers and multiplies them together, just for the sake of demonstration. So we're going to pass in, let's say, two numbers, 5 and 5, and we will get the result 25, all good. But if we go back to our terminal, we can see that this line was added as we ran it. So it says something about the reactor component. It references the jobs, and then it says 14 steps. So what does those 14 steps mean? Well, if we go into the trace file, we can see that there's a line here now. And this is unbelievably unreadable for a human. But in the latest VS Code extension, Hantera Studio, we have the Hantera debug window. And from here, we can load this file into VS Code like that. Now we can see here, there's one line. And if I click on this line, I get these entries and I get the result symbols and I get the values. And this is essentially a tree representing the whole evaluation of the program. So we can see that the result was 25. And if we dig into this tree, we can go step by step. We can see the value, for example, that was passed here. It fetches value from the parameters. It was a list of 5, 5. And then it got the function that it wants to run. And then inside of that function, it calls the reduce, which is a runtime function. And reduce fetches the series, which was, again, the argument passed to the function, 5, 5. And eventually, it runs the reduce function for each entry in the series. And it's a multiply here. And we can see that there are two multiplies. And that's because this ran 2 times. First, it ran and it output 5 because res was 1 and item was the first 5. We can actually see that if we go into the multiply node here, and we can see that it got res, which was 1, and the next one was item, which was 5. And we can also see here in resolve symbol that item and res was 5 and 1 at the time. If we go back up to multiply, we can see that the output is 5 from the first one. And then the second time, well, it got the 5 from the previous iteration, and then it times that by 5 again, which resulted in 25. That's nice because we can now literally go back in time, right? We can go from this one back to where we were and look into how did we get to that, and it's all good. Now, this was a job that we ran, and I said in the beginning that any component that runs will be captured. So it doesn't matter if it's a reactor run as part of a job, or if it's a rule, or even a promotion, they will all be captured. Furthermore, ingresses will also be captured. So in this app, as an example, we have an ingress that runs the same reactor, and it binds to this route, and we can pass in the value as part of the body. So we have a sample request here where we do exactly that. So we pass 555 as the value parameter. And if I run this, we will see down here immediately as I run it, we will get another entry. And it looks slightly different because, as I said, it was an ingress request. And if we press on this, we can see the request itself rather than just the evaluation. So we see the full request headers, we capture the body, and we capture the response body as well. So we get the request and the response fully logged. This is invaluable when you are developing webhooks, for example, or capturing, receiving webhooks. You can really just capture the request. If you want to redo it, you can just redo it because it's just an HTTP request. Inside of the ingress, we also have the reactor component, which is the thing that runs inside of the ingress to produce the actual result. And here we can see now we have 3 multiplies because we passed in 3 5s in the list. And obviously the last result here is 125, which is also what we got from the response. So that's nice. Another thing you can do is you can open up an evaluation like this, and you can press this little flag, and this will give you a heat map of all of the code that has been running. This means that you can see code that didn't run at all, and you can see hot paths where some piece of code ran a lot of times. In this particular example, we can see that this section here is slightly more green, and that is because it ran 3 times as opposed to this code that only ran once. And that can give you immediately an indication of possibly a performance issue, or just to know where it'd be interesting to look closer into your code, which you can do also by just placing your camera anywhere and press this little filter button, and then we get all of the entries that ran through this piece of code here, which was only this get really, and that really helps you to quickly navigate. If you have a large component of, let's say, 50 to 100 lines of code, you can just put your caret there and filter, and it will only show those. And then you can obviously remove the filter, and you can see the whole tree and whatever happened around it, no problem. So yeah, this is available in the latest Hantera release. It is still heavily under development, but this has been so useful for us internally that we just felt like we have to release it, because it really changes the game. The stuff that took possibly hours before, now it takes only a few minutes. You only have to really run your test cases once and just capture all of the data, and then you can step through each and every execution back and forward. You can search through and really find the problem, and obviously then you can make a change, and you have the bug fix ready to go again. So yeah, I'm really looking forward to see this being used. And as I said, we are using it a lot ourselves. We have additional improvements coming to the VS Code extension shortly, which will help even more in app development. So stay tuned for that, and have a good day, everyone.